plants' behaviour by Andrew B.T. Barron, Richard Maleska, Paul G. Hellawell and Jeannie Robinson. Introduction. Cocaine is a neurotoxin that protects the coca plant, Erythroxylum sp, from herbivory by critically disrupting insect motor control. In humans, cocaine is also highly toxic at medium to high doses, but highly rewarding and reinforcing at low doses and potentially addictive. Why should a chemical that evolved to protect plants from herbivory be rewarding to humans and other mammals? This has been called the paradox of drug reward. Solutions to this paradox often propose that cocaine evolved to deter insect and not mammalian herbivores, and that fundamental differences exist in the responses of mammals, especially humans, to cocaine compared with those of arthropods. Seemingly in support of this view is the observation that while there is abundant evidence for cocaine disruption of insect motor systems, it has not previously been shown to be rewarding to insects. New data, however, have revealed many similarities in neurochemical systems and cocaine's mode of action between insects and mammals that call into question this solution to the paradox of drug reward. In both mammals and insects, cocaine operates by blocking biogenic amine reuptake transporters, thereby disrupting biogenic amine signaling. In mammals, the biogenic amine systems disrupted by cocaine, principally dopamine, modulate both motor control and reward processing. In insects, biogenic amines, principally dopamine and octopamine, also modulate motor control, arousal, and reward processing. Given these mechanistic similarities, we revisited the question of whether cocaine could be rewarding to insects. We used the dance language of the honeybee, Apis mellifera, as a natural bioassay to study the effect of cocaine on reward assessment. On return to the hive, forager honeybees may perform highly stereotyped movements, dances, to signal the location and value of floral resources to their nestmates. The function of the dance is to advertise profitable resources to improve the foraging efficiency of the colony. For resources close to the hive, bees perform round dances, and the likelihood and rate of round dancing are related to the value of the resources. Resource value is influenced by several factors, including the costs and benefits of the foraging trip and the nutritional needs of the colony. Bees use these factors to develop a Gestalt estimate of the value of collected floral resources to the colony. Dance thus provides a unique, natural and quantifiable assay for a forager bee's assessment of the value of collected floral resources. Here, we use the dance response of forager bees to sucrose and pollen feeders as an assay to assess the effects of cocaine on honeybee reward processing. We examine the effects of chronic and acute treatment with low doses of cocaine on honeybee behaviour and found honeybee responses that paralleled those of mammals. Materials and methods. Experiments were performed at the Australian National University Research School of Biological Sciences, Canberra. Bees used were the standard commercially available hybrid of various European races available in Australia and were reared according to standard beekeeping practices. Pharmacological treatments. In these experiments, bees were treated with freebase cocaine, octopamine hydrochloride or meancerin hydrochloride by applying the compounds dissolved in 1 microliters of dimethylformamide, DMF, to the dorsal thorax of forager bees using a glass microcapillary while they fed it sucrose or pollen feeders. DMF is a solvent that can penetrate bee cuticle and act as a vehicle to allow administered compounds to pass into the hemocoel and reach the brain. Experiment 1. Effects of cocaine and meancerin hydrochloride treatment on dance behaviour dances were observed using colonies of 8,000 bees housed in a glass-walled observation hive. Individually paint-marked foragers were trained to a 1.5 mole sucrose feeder 10 metres from the hive, and their round dances were video recorded during a 50-minute period. We compared the round dance behaviour of bees treated with a single acute treatment of 3 microgram, 6 microgram or 12 microgram cocaine dissolved in 1 microliter of DMF. Control groups were sham treated, simply touching the bee's back with an empty glass microcapillary, or treated with 1 microliter of DMF only. Inclusion of both sham and DMF treated control groups allowed us to determine whether DMF itself was affecting behaviour. Bees treated with 2 microgram octopamine in 1 microliter of DMF were included as a positive control, since octopamine is known to modulate bee dance behaviour. Dance observations began 20 minutes after treatment. During the observation period, the number of visits by each bee to the feeder was also recorded. Videos were later analysed to score how many feeder visits caused dances on return to the hive, dance likelihood, and the rate of dancing, number of dance circuits per minute. Mianserin, hydrochloride, is a biogenic amine antagonist. To test whether cocaine influenced dance behaviour by affecting biogenic amine signalling, we examined whether mianserin treatment could reduce the effects of cocaine on dance behaviour. In a separate experiment using a different bee colony, we compared dance behaviour in bees treated topically with 3 microgram cocaine, or 3 microgram cocaine plus 2 microgram mianserin. We have shown previously that this dose of mianserin does not make bees sick or reduce dance performance on its own, but is an effective antagonist of biogenic amine treatments. Control groups were sham, DMF, or octopamine treated. Results. Effects of cocaine and mianserin hydrochloride treatment on dance behaviour. Cocaine caused a dose-dependent increase in both likelihood and rate of dancing. This is consistent with how dance behaviour would be predicted to change if foragers were reporting resources of greater value. These effects of cocaine on dance behaviour are similar to those for octopamine, which is known to modulate reward processing in insects. The effects of cocaine on bee dance were eliminated by simultaneous treatment with the biogenic amine antagonist, mianserin, suggesting that cocaine modulated dance performance by interfering with biogenic amine signalling. Effect of mianserin on the stimulation of dancing by cocaine. Dance likelihood and dance rate of bees treated with mianserin and cocaine for a 1.5 moles sucrose feeder were compared with dances of bees treated with cocaine alone and DMF and sham-treated controls. Cocaine-treated bees still forage normally and effectively between dance bouts in the hive. This result suggests that cocaine treatment within this dose range did not damage the ability to fly, locate the feeder, and collect sucrose. Cocaine-treated foragers only danced when they were interacting socially within the hive. Foragers treated with cocaine but held in small vials isolated from the hive never performed any movements resembling dances. This indicates that cocaine stimulates dancing only in the appropriate social context of a forager returning resources to the colony. Discussion. In summary, cocaine treatment caused a dose-dependent increase in the likelihood and rate of dancing. Dances for sucrose and pollen were both affected by cocaine, and these effects were eliminated by treatment with the biogenic amine antagonist, mianserin. Cocaine also increased sucrose responsiveness in the assay, and bees performed poorly in a learning task following withdrawal of chronic cocaine treatment, but not with continued chronic cocaine treatment. Cocaine treatment dancing did not stimulate general locomotion. The behavioural function of the dance is to advertise profitable resources to nestmates, and the effects of cocaine on dance behaviour are consistent with cocaine increasing responsiveness to floral rewards. Hence, we argue that our experiments present the first evidence for cocaine modulating reward processing systems in an insect brain. However, cocaine is known to modulate motor systems in insects, and in Drosophila, treatment with medium to high cocaine doses can sometimes release looping locomotor stereotypies. Therefore, an alternative interpretation of our findings could be that cocaine affected dance behaviour by stimulating motor and not reward pathways in the insect brain.